Uh-oh.
Yeah, plus I think it was I think that soft is also used in gems.
Yeah.
So it's even easier.
I'll ping Carlos when I see him. See him there yet?
I think it's that concepts.
Hey, Donald. How you doing? How's things? Good, good. Yeah. Yeah. Oh. Yeah. All right. Yeah. There's Carlos.
Carlos. It's just an update on the prank. Yeah. Just really an update. The documents. It's fine. Whatever was added. Focus being put on. Okay, we'll put you on. So we put you on for Greg. Seriously.
Anytime. No, I'm joking.
No, you are first. You're first.
Really?
Yeah, you're scheduled to be first.
That's okay.
So we can move you to after.
No, it's fine. I think it's better to do it before the. Sure, no, I don't know how to miss it.
We'll give you 30 minutes.
No, really, I don't know how to miss it. So I'm gonna speak to myself.
Yeah, okay.
Their losses I do.
We have 5 minutes. Oh, yeah, we have. It's 3:55. It's not 3:50. You're going to need just about in the middle, how you've got access to it.
I at least have the agenda sitting next to me.
Okay, you're getting less and less busy.
Let's get it started.
You want to pull them to order?
I can't reach. Hello, folks. It is now 5 minutes after, more than 5 minutes after the scheduled start time. So we are beginning the session. I'm Joel Halpern. This is Jim Gishard. We're the chairs. Our thanks to Tal Mizrahi, who will be officially our secretary, but has been taking notes. Ignaz Bagnaz, who's also taking notes. Sorry, I probably mangled your last name again, Ignaz. I'm bad at that. And welcome, everyone. We have a bunch of items to present, and then, as we said on the list, time for open discussion of what things people believe the working group needs to work on. Because NSH is going to go to our AD very shortly. There's like one more item to fix on that. The note well is here. You should know the note well. Note it well. Everything's a contribution. We'll go through the agenda. SFC, OAM, got a series of presentations. Carlos is going to start by giving us an overview of where the framework document stands, and then there are a number of other documents. Adrian will then talk to us about the next protocol none or convent draft. There's a presentation on dynamic service chaining and indirection, and then we'll be on the rechartering and other maybe topics that are already in the charter but we haven't done. Whatever you guys feel needs to be done. And what we'll probably do is use the left-hand mic to introduce topics. No, my right-hand mic, your left-hand mic, and the other mic for any follow-ups on a topic that somebody wants to bring up, so that we make sure we discuss one before we move on to the next. Agenda comments, well, we move on. There's the agenda in more detail. Okay, Carlos.
You're up.
Hello, Carlos Pignataro, Cisco Systems. I'm going to talk briefly about SFC OAM and essentially where we've been, where we are, and the forward-looking plan on what we intend to do with OAM. OAM in this working group has been a topic that was interesting because of two somewhat opposing forces. The first force was that there's a lot of people and customer requirements that are fairly fundamental on OAM and what it really means to have OAM on an SFC. We had a lot of early discussions. We said, going all the way up to the application is out of scope, but we need to actually test and do various OAM functions on the service function path themselves. On the other hand side, there has not been too much of a deliberate focus on it. So even though we said as a working group, this is something important, critical, we spend our time and cycles on the architecture, then follow on with the NSA and a number of adjunct documents. Like Joel was describing, we're at the point in which the NSH-based document is getting ready to be sent to ALIA. And because of that, or in preparation of that, the chair said, okay, so let's be intentional about looking at OAM again. So we looked at the landscape of different OEM documents and functions, and we had one document, which is the OEM framework. At the time, we adopted that document as a working group, and the main reason for that was because we wanted, without necessarily have the destruction of a lot of protocol specifics and bits and bytes, we wanted to have a single place that consolidates the overall OEM thinking before diving into, okay, we're going to do this for performance management, we're going to do this for trace route, we're going to do this for whatever else. So the time has come now to actually look at that document again, and that's something that we did in the past month and a half or thereabouts. We consolidated that document, who was actually started by Sam Aldrin. Sam Aldrin, on the very, very initial version of draft Aldrin SFC OEM framework, he laid out exactly that, the framework of copying the architecture and the different OEM functions that need to happen. We took on that same document. We did all the editorial updates that were needed, but we also added a new section, which is the main topic that I wanted to talk today. And that main section is actually a listing of the currently existing or within scope, or that we're looking at OEM tools within SFC. And I'm not sure, I know people are looking there, but I don't have any slides, so I wasn't sure if there was something interesting being projected. I know. So anyway, the idea right now is to take that as the anchor point for the OEM conversation. We have the framework, the functions, and then the protocols that we're evaluating. All of those are listed, and in particular, we also added at the very bottom of the document a table mapping OEM functions to OEM protocols, right? So we have a section on the functions that are important. We have a section on the protocols, and we have a matrix that is essentially correlating one to the other. This document is being restarted right now. It's in revision 2 after being dormant for some time. So the plea, the request is for people to look at it, not only the differences from the previous version, but rather look at it as a whole, because the forward-looking plan is to use that as the anchor point for OEM. And from there, potentially how we do some additional protocol specifics. That document is not defining protocol, it's laying out the framework on SFC, the functions, and available existing protocols. So with that, I'll take questions.
Okay, I just want to ask chairs, because there is a Q&A section allocated at the end of all presentations. So would you suggest hold questions to that part, or use this time?
We should take questions specific to the framework, should probably go now.
Okay.
And then I was going to point out that we'll take all the questions on all of your presentations at the end of all of yours.
Thank you.
But the framework right now.
Okay, Greg Mirsky, ZTE. I have one concern about the turn this document is taking. The document in the scope states that specific protocols and mechanisms are outside of the scope of this document. And even though it's already been agreed by the working group of the scope of the document, we now have some discussion of specific protocols getting into the document. So I think that the gap analysis section and the new section should be removed from the document.
Thank you. I don't remember by heart that sentence that we're not going to talk about protocols. It really is for us as a working group to define. That additional section is intended to be an aid and not a structure. It's intended to be an inventory of existing capabilities, so that, when we looked at the document being dormant after a while, we realized that it was a little bit fluffy and contentless. And one thing that we're trying to steer away from is to have a framework that talks about a framework and requirements of a framework of the architecture. We want to bring it to reality, and that is the main intent of doing an inventory of protocols. That said, the document is not defining protocols, is not making decisions about what protocol to use for which case, is listing an inventory.
Okay, I think that, and we had this discussion in part of the discussion of NSH document, and I think that we agreed that there is immediate need to give a clear definition of what OEM packet is and what OEM packet is not. So I think that if we extend the scope of the document, that will take us much longer to get this definition that we can standardize and agree on and keep on working. So I would encourage keep the scope as being originally defined and concentrate on solving immediate need of the working group. So and keep the discussion of benefits of this or that specific protocol and mechanism outside of this document.
Thank you for the comment. So 2 quick follow-ups to that. The first one is that, Greg, when you talk about an OEM packet, you're making a set of assumptions. And part of the assumption is that there's a new OEM packet for SFC. When you're talking on the second part of your comment about focusing on what we need with time to market, and I'm paraphrasing, let's not try to reinvent. Let's actually look what's out there and what helps us solve each problem. I don't think the work of the OEM framework is not intended to define the OEM packet, because there may not be such a thing.
Okay.
To move on.
Again, my view is that if we start listing existing or upcoming solutions in this document will never see any end, because it will be never-ending story.
We can always...
Okay. One more comment, and then we need to move on. This is coming out of Greg's time to the next several presentations.
Yeah, Sam Aldrin. If we don't refer what exactly is there and how we're going to use it, there is no way you can actually reference and show that, okay, things are what exactly being asked. And we have to do that. Whether we are not prescribing a solution here, we are just prescribing, saying that what is out there, and if at all we need a new definition of an OEM or packet, feel free to propose a solution. If you don't need it, that's also good.
Okay, even it comes from my time. I think it's a task of authors of their specific solutions and protocols to explain what they're solving and how they're solving.
That goes to the specific drafts, not in this draft. How would they do that? This is just referencing as a FII, saying that these are the solutions which are already in existence within the IETF in form of drafts. Just go and refer that.
All right. The takeaway from my side, as editing the document, is that we want to move forward with this. We don't want to lose cycles with this, with a lot of discussion. So we really invite comments, review on the list. Thank you.
We can take that to the list, but Greg and Ting need to come up now, because we have a series of more specific OEM presentations, and they're going to be going back and forth. I don't know what the exact, who's presenting which thing, but they know that.
Yeah, I will start and Tim will.
And I have all of your presentations queued up.
Okay. Yes. Okay. So the multi-layer OEM SFC networks. Let's go next. Again, so this is an update, and I don't give the scope of their current document. So if somebody has some questions, feel free. As we indicated, we will make a series of presentations, and then there will be Q&A section. So we look at SFC or a task of SFC OEM as a multi-layer OEM, whereas we have SFP OEM, and then we have SF OEM. And the point of view is that the SFP, it's end-to-end, and SFF to SF, it's a local OEM matter that can be queried and exported and reported to the querer. So just would not read their list. Now it's a part of their materials, and you can find in a document as well. Where should I point it?
Clicker should advance.
Yeah.
No, okay. Use the verbal advance mechanism.
Okay, next. Yes. Okay, so that's the demonstration is that, so SFF form layer 1 and SFs, they form layer 2 in a multi-layer SFC OEM model. Oh, specifier R. And let's go next. So the first and foremost probably will be used too is well-known echo request, echo reply. And when we look at it is that we look at that it must have certain information included. One of them, it has to have SFC source TOV, so the identity of their node that generated their echo request, so that echo reply can be properly sent. And there needs to be allocated UDP port for the sender to listen to and receive the echo replies. So that's two updates being added to the document with appropriate IANA consideration. Okay, next please. So we'll continue working on this document and appreciate your reviews, comments, suggestions, and maybe not this time, but at some point ask for working group adoption. Okay. Next presentation, I think we'll take.
Questions on that document later or now?
Later.
We're going to do them, all of them.
Block,
Yeah.
because otherwise it's going to get, we're not going to make the time at all.
Okay, good afternoon.
You need to pull the mic down and talk closely to it.
Okay. Okay, thank you.
Works too.
And the following two slides is about SFC pass in SFC OEM. And the first is return pass in SFC OEM. I know we are discussing about SFP direction in mail list right now. But in these slides, we are assuming that SFP ID is directional. Next. As we know that OEM has four modes to control the path of echo reply. One is do not reply, and the second is reply via IPv4 and IPv6 UDP packet. And the third is via application level control channel. And the last is reply via specified path. And this slide is going to specify the SFC OEM in reply via specified path. And we want to specify SFP as the return path of the SFC OEM echo reply. For this requirement, one use case is for bidirectional SFC. A reverse SFP is indicated in echo request, so that SFC can be checked in both direction, forward direction and reverse direction. Next. To specify a reverse path in SFC OM echo reply, we define a new TLV. We name it reply service function TLV. And the TLV is in echo request to indicate the specified return SFP. The following figure is the format of this TLV, and the TLV contains the reply service function path. One part of it is reply service path identifier, and the other is service index, and both of them is used for reverse echo reply forwarding. Next. Here's the operation of the SFC-OM with specified return path. First, we should set the value of reply mode to the reply while specified path, and include SFC reply path TLV that is defined in this draft in the echo request message. The SFP ID in the reply path TLV should be the identifier of the return path. And next, once the SFF want to reply the echo reply, and the echo reply should use the SFP ID and SI as its NSH header. And if the return SFP can't be found, the echo reply should include reply SFP as not be found in return code. And if the reply path theory is not provided in the echo request with the reply while specified path, and the echo reply should include the reply path theory is missing in the echo reply in return code. Next. And that's the main content of the slides. Any comments and questions are welcome. Yes, this is the second slide about SFP path. Next, yeah. First, we want to have some background review. For the SFC, we know that SFC is a chain with a series ordered service functions. That means the order of service function is very important. And the SFC-OM is operation, administration, and maintenance for service function chaining. And we already have OOM, overlay OOM, that can be used as one of the solution for SFC-OM. And it is in-band OOM, and our solution is based on this OOM solution. And the path consistency is that every SF, the packet transmitted is consistent with SFC provision that we want to check the path consistency. Here we define COM, that is consistency OM, that is used to check the path consistency. I mean the order of the SF in SFC. Next. This is the COM messages we defined in the draft. There are two kinds of draft. One is the COM request, and the other is COM reply. And COM request is the SFP consistency echo request. It should be sent from the ingress of the SFP and forwarded by every intermediate SFF. And for COM reply, SFP consistent echo reply. Every SFF receiving a COM request should not only will forward the COM request, but also send back a COM reply. The COM reply message contains the information of SF that is connected to the SFF. And the previous slide. Yes, and the figure in this slide is about the format of the sub-TLV as SF information. And there are some information about SF, such as SF type, SF service index, and SF ID type. For example, IPv4 or IPv6 or MAC address, etc. And the last is SF identifier used to identify each SF. Next. Here's the COM operation. From this figure, we can see that once the ingress of the SFP send out a COM request, every intermediate SF in this SFP should forward the COM request forward to its next SFF. In addition to that action, it also should send out a COM reply to send out a COM reply back. And the COM reply contains the SF information that the SFF connecting. From this figure, we can see that with clearing the COM reply 1 and from SFF1 and COM reply from SFF2, etc., we can get that the SFP is contained SF1 and SF2 and SF3 and SF4. That's the path of this SFP that we checked. Next. Yes, that's the main correct content of the draft. Any comments and questions are welcome. Thank you.
Okay, so yeah, we can go to the next slide. What we're proposing, we're describing how alternate marking method can be used to measure packet loss, delay and delay variation, and mean delay in SFC. Proposal is to allocate 2 of reserve bits in a NSH-based header and refer to them as a mark field. And one of the bit flags will be used for single mark method. Another will be used for double mark method. We can go next. So just briefly, single mark method is based on creating batches of similarly marked packets, data packets in the flow. And there are 2 methods to do the marking. One could be based on the number of packets, so switching or reversing their single mark every n packets. Another could be on a time. Time is more preferred technology because even though it's susceptible to packet loss and out of order delivery, it still enables us to do pretty lightweight average delay variation calculation. Basically, arrival time being calculated at each node and then divided by the number of packets in the batch, that's giving us average delay on packet. Next. With the double mark method, what's used is that the second mark, D bit in the mark field, used to create timed packets that can easily be identified in a batch. So you can imagine if we say that this batch has a color, so we're switching colors, let's say red and blue. And in between red or blue will just identify the packet that will be very easy to do timing. And then this information can be collected out of band from the nodes to do correlation and then calculation of very precise and accurate delay and delay variation. So we can go to the next slide. The advantage of this performance measurement with alternate marking method is that it can be easily instantiated end-to-end, and what we envision that classifier will be doing marking, and in this case, SFF3 will do the measurement. But if we notice, if operator notice performance degradation, then the method can be activated on each of transit entities that part of this SFC, whether it's SFF or SF. So you can go next.
Just a small question, Greg.
Given the bit, one more presentation.
Sorry. Oh, okay. All right.
Okay, and yes, I want to mention that in IPPN working group there are some. Well, we do have discussion on new marking methods that might not require 2-bit field.
All I was going to ask is why don't you make it an enumerator rather than a bit field, because bits are precious by the look of it.
Oh, you mean so the field which is okay. Okay, I need to switch probably because I'm things slowly. Okay.
Okay, this slide is want to have a discussion about the interworking of SFC and its underlying network.
Next slide.
First, I want to state my questions about the SFC. At present, SFC is based on their transmitted over an overlay network. We can see that in NSS draft section 7. But we take Geneva as an example. If SFF and NVE are co-located, NVE knows how to encapsulate the NSH packet with an overlay header and forward it to the right NVE. So that's there's no problem at all. But if for the situation of SF and NVE, these two functions are splitted, there's some problem that NVE don't know how to forward the NSH packet to the right SFF. Sorry, because it doesn't know which NVE is its next hop. This is the figure in this slide is the example of the problem, and the NVE and SFF is separated. SFF1 in this figure knows its next hop is SFF2 according to its SFPID, but it's connecting to NVE1. NVE1 doesn't know its next hop is NVE2. This is the problem of SFF and NVE separated. Next. So for this problem, we propose to our NSH that first specify how to add NSH for an original packet, which is not specified in NSH draft right now. When add NSH header, how to encapsulate the original packet, including IP header or Ethernet header. This is suitable for SFF and NVE separated. And next we propose is when SFF find the next hop in SFC, it should find the next hop address according to its SFPID in SFC header of the packet, and then for replace the destination address to the next hop address in the IP header or Ethernet header. There's a figure as an example. We also take the SFF1 as an example. The packet, these two packets is one is forward to SFF1 and another is forward from SFF1. And For NVE1 to SFF1, the NSH packet destination address should be SF1. And after the process of SF1, SFF1 to NVE1, the packet SF1 should change the packet destination address to SF2, because SF2 is its next hop, so that NVE could know how to forward the NSH packet and encapsulate the packet to NVE2. Next. Okay, that's the situation. That's the problem and my proposal to state. Thank you.
Okay, so I think that now we're ready to take questions.
Yes. Stuart, you had a question?
So there's questions on any of those presentations.
And I'll happily bring up whichever presentation is needed. Looks like you were first.
Sam got there first.
Sam Aldrin. How do you ensure the OEM packet doesn't muck around with SF?
Well, that's basically in the first presentation. In our model is that OEM, again, here's the question is, what do we understand as OEM packet? If we understand OEM packet as 7799, the packet is specifically constructed for the test purposes and generated in the SFC domain and consumed in SFC domain, then our proposal is that end-to-end OEM in SFC is done on SFP, so classifier and SFFs.
How do you know each of the SF support your OEM encapsulation?
Again, the intention is that the packet doesn't go to SF. The packet traverses SFFs, and SFF to SF is a local, it's a different layer of OEM. And how it works based on mapping, and then SF can be augmented to indicate to SFF what type of OEM it supports.
So in your layering, multi-layering draft, what you're saying is you're pretty much measuring between SFFs, nothing to do with SF.
Again, with active OEM, yes. With the proposal of using alternate marking method, you don't have to do that because you're using NSH header to mark data packets, and you can do a performance measurement that involves not only SFs, but functions as well.
So I'm still confused. If you're sending a packet which traverses through SFs, it has to traverse through SFs, correct?
No, it can touch SFs. As it can basically their active OEM that goes SFP OEM doesn't have to touch SF because you can go SFFs, and if you have requests for information as indicated in the presentation that Ting done on consistency. So this information can be obtained from SF by SFF and reported back to their sender.
So in other words, you're not actually testing the SFC.
Well, you're reconstructing information on SFC because, yes, I agree with you. There is a problem of functionality, what is supported by SF.
There was an earlier, at least in an earlier version of the framework document, we were very clear that we were not attempting to test the functionality of the service functions because an OEM packet can't test the functionality of the service functions.
I'm absolutely clear on that statement, but my understanding is if you're sending a packet, it is traversing through SFs or not.
Well, we're going to have to define the handling of the OEM packets. That's our job outside of the NSH document.
So I'm talking specifically for...
We need to let other people ask questions too, please.
Okay.
Stuart, you were next.
So I kind of repeat the question I had before. You've got only a few bits. You seem to be only using doing one OEM measurement in a packet. If you made it an enumerator, 1, 2, 3, 4, 5, 6, 7, you would be less likely to run out of bits than having 1 bit per function, and it's just as hardware friendly.
No, again, okay. There are some ideas about how not to run out of bits and how not to ask for bit per function. The marking method is the method of identifying the packet that needs to be used for measurement. What type of measurement can be, context of measurement can be set out of band.
I just think you might end up with another sort of measurement that you want to take that's mutually exclusive, and so being frugal with the bits would be a wise thing.
Oh yeah, but thank you for a suggestion, and we'll discuss it.
I believe it was this side and then Adrian. Go ahead.
Go ahead.
Yeah, that's your next.
Chen Zhonghua from China Telecom. And in the development, in the deployment of the SFC, we think the management is can be divided into 3 parts, and the underlay network management and application monitor and the SFF layer management. So in the front 2 parts, we have many tools to manage these 2 parts. But in the SFF management, we have no or few tools to manage it. So we think it's very important to discuss the SFF management in this work group. So my suggestion is we should consider the SFC proxy in the SFF layer management, because the SFC proxy is different from the common SF. It's connected to the traditional network and the traditional application. So we think it can be considered in the draft.
Thank you. It's very helpful, very interesting proposal, and I would like to have some more discussion about it. Thank you.
Adrian?
Adrian Farrell. So following up Sam's question, and please tell me I wasn't listening if I missed something here. It sounded like the proposal was that we would trace through an SFC, SFF by SFF, and not trace to see whether a specific SF had been called in. And that worries me when SFs can be remote from SFFs. So if they're tunnel attached.
The last text we saw was that monitoring of the connection between the SFF and the SF is viewed as a separate problem. It needs to take place. But they're using these OAM packets is not the way to do so.
I do not mean monitoring the connection. I mean monitoring which SF is at the end of the connection. So it's not enough to trust an SFF that, oh, I've sent the packet to an SF. It's not even enough to trust that the tunnel that the packet has gone onto is coherent. What you actually need to know is the SF at the end the SF I thought was at the end?
Okay, yes, it's a valid question, and in a consistency OEM draft, what we proposing is that the query, the echo request that comes to SFF triggers some mechanism to query SFF, to query mapped SF that belongs to this SFC, and then report it to the querer. But it's not necessarily the same packet that has to traverse SFF to SF.
So I hear that and asked only, do you trust the SFF to tell the truth?
Well, I think that the whole thing of OEM is based on certain assumptions.
Well, as Jim just pointed out to me, the other path is the in-band, in situ OAM approach, which does go through the service functions. But those are a different set of tools. These are a set of tools they are suggesting, not the only tools that we as a working group are allowed to consider. In fact, one of the things I'd love to hear in just a few minutes, but we got 2 more presentations first, is what other OAM work do people think we need to do? But there was another question here.
Yeah, it's Kent Leong. Actually, just I had one comment, but I want to answer that one too. So I think there's also the interface between SFF and SF in this case. There might be issue with load balancing, right? You may have multiple SF instances, right, that you have to deal with. So the whole OAM of confirming your service path, or SFC in this case, probably have to take that into account as well. But that was more of a comment anyways. I came for a different question. It was for Ting's presentation. It was mentioned that we don't have Ethernet native, which I mean, I thought we do support Ethernet NSH. So I know you said there's IP and Ethernet, but maybe IP we don't, but Ethernet I thought we do. So I don't know if that's just something I missed.
Let's be clear. We're not mandating any transports, but it is expected that people will be using IP as a transport, will be using Ethernet as a transport, will be using MPLS as a transport, will be using VXLAN, GRE, the list goes on. We're not mandating any of them.
That's right. Yeah, but I thought the issue with the
NVE, the network virtual overlay issue, is a somewhat more complicated issue. And since you've asked, let me comment that the real key there is the service the SFF sees is an Ethernet service. It's going to address things from the Ethernet perspective. That's all we as an SFC working group can deal with. The question of how an NVE receives an Ethernet frame, delivers an Ethernet frame, that's the network virtualization overlays problem, not that's delivering an Ethernet service, not an SFC problem. So from SFC's perspective, the service, the transport that the SFF sees is whatever service the overlay provides. When the overlay is co-located, then the SFF may be aware of the overlay and be working more closely with it. But otherwise, it just uses the overlay as every other entity uses the overlay, and that works. It creates more layers of overlay, but it still works. So there's different kinds of assumptions people make. Some people assume the SFF will be closely coupled with the NVE, in which case you can get one kind of behavior. And as you validly point out, it does not have to be closely coupled, in which case the SFF simply works in terms of whatever the service provided by the overlay is, which may be an Ethernet service, and then it's SFC NSH over Ethernet.
You're right. I don't want to get too long into it, but I thought Ting's point, I was trying to understand it too, but if it's going over native IP, I think that's maybe an issue, right? So, because we, like you said, we're going over any overlay, right? If it's GRE or NSH GPE, VXLAN GPE, right, or Ethernet, that's all supported. But I think going over native IP, I don't think we support that. And I'm not sure that was your point. But anyways, I could take that offline with her.
That's also allowed.
Yeah.
Okay. Adrian?
Sorry, just for the note takers, please state your name very clearly. Okay, thanks.
Good point. We should have hammered people.
Okay, so I believe I have just 5 minutes to run through slides, and then we have some discussion time. For reference, I was going to call this draft Farrell SFC superfluity, but I thought that would be rude. So the collective noun for nuns is superfluity. Next slide. So what's going on? What we know about metadata is it's carried in the NSH, and that we insert the NSH between the forwarding header and the payload packet. So metadata can be sent whenever there is user data packet. And the question I was asking myself is, what happens if there is currently no user data packet in hand? In other words, there is no packet going down the SFC, but I want to push metadata. I want to program, if you like, the SFC with some metadata. Or what if the metadata I have, which I guess is a type 2, is too big to fit into the packet for some MTU reason, or just because it's a lot of metadata? So next slide. What we also know is that there's the next protocol field, and it lives in the NSH, and it identifies what comes after the NSH, including metadata. And the NSH document, sorry, I wrote the slides before the last revision, includes v4, v6, Ethernet, MPLS, and NSH for recursion. So our proposal here is to say, let's use 0 to mean none. The next protocol is none. It means there is an NSH, but there is no user data following the NSH. And this gives us the opportunity to send packets containing metadata, but no user data. So we can push metadata around the network without having to wait for a packet. Next slide. What happened? What happened is we used one well-known operating system instead of another well-known operating system. If I could dance, I would at this point, just to keep you entertained. I could sell you a book of fairy stories. How about that? Right, use cases. Use cases, of course, are not limited to my imagination, so anything you want to do, but I think there are a couple of things. Metadata may apply to a whole SFC, so it's something you push through and say, any packet on this SFC, now here is the metadata. Or you might push it through for a flow that's on an SFC, where a flow is probably defined by the 5-tuple. So today you would say, I'll wait for a packet, a user data packet, and I'll attach the metadata. What this allows you to do is just send it when you're ready to send it. And this is similar to some proposals, and I think MED's control plane draft talks about this, where you would install metadata out of band using some management protocol or netconf or whatever to push metadata. So this is pushing it horizontally rather than pushing it from a controller. It also allows you to communicate between SFIs so they can coordinate with each other, which I think quite often they need to do, especially in the security world. Or it allows you to build a control and management channel through your service function overlay. And obviously, if I mention OAM, then we can all start throwing food, so I won't mention OAM at all, not even slightly. What is specifically not a use case, I believe, is per packet metadata. And by that I mean metadata that it might be computed on a packet somewhere in the network, applies to that packet only, and then the next packet along uses different metadata. So, for example, a hash, it falls into that category. And that, if you had a set of pre-installed metadatas, like a whole field of a table, then you could use this approach by putting an index in, but personally, I wouldn't go there. And next slide. I will come, but yeah, let me just, something we discovered was maybe unclear in the NSH document was how you process an unknown next protocol. So we thought we should clarify that in this document. Whether that gets ripped out and put somewhere else doesn't really bother me, but it needs to be written somewhere. So what we think is SFFs forward packets, even if they don't understand what the next protocol is, because they don't look into those fields. SFC proxies are responsible for only delivering packets that their SFIs know how to handle, so they would drop the packets if they don't understand the next protocol. And SFIs that are SFC aware would fall into the same category, except possibly you could configure them to say, if you don't know what the next protocol means, just return the packet to the SFF. But I think that's unwise, especially in security implementation, so I would expect them to drop the packets. Reclassifiers, similarly, I would expect them to drop packets because reclassification is about knowing about the payload, and if you don't understand the next protocol, you don't understand the payload. Right, discuss. I'm not going to stand up here while you discuss it, I think.
So I wanted to comment on that last slide there, Adrian. On the SFF, wouldn't you say that if the SFF is the last SFF, then potentially the next protocol is important if it's doing declass?
You have a very good point. Yes, if you strip the header and forward and you don't know how to forward the payload, then you had probably better not forward it.
So we should probably update
Yeah.
that. Yeah.
The questions for me should be distinguished from questions from discussion, I think.
Dan Bogdanovic, when you said you don't want to mention OAM, with this we are following exactly the service topology, and when you started presenting that, that was the first use case that I had in mind.
Yeah, to you I'd say, yeah, no shit. OAM is a use case I have in mind, but I also am aware that the working group may want to come to a decision on how to address OAM collectively rather than have it dictated by me. Maybe?
Carlos, and then back.
Carlos Pignataro, Cisco. Could you please go back, I think it's one slide here to the use cases. So first, I find this very useful. I have a question on the first bullet, Adrian, when you say per SFC and per flow metadata. I'm not sure I understand what you mean by per flow. You could potentially have multiple payload level flows within an SFP that you're not going to be able to distinguish unless you have a payload.
Yeah, you don't have a payload. Where are you getting flow?
Right. So the question could be, how do I understand which flow this metadata applies to when it's coming along without user data? And the answer is, you need to put some information in the packet that indicates it. Okay, so there's an OAM packet, it's got there's a metadata packet, it's got metadata in, it's intended to apply just to a subflow on the SFC. You had better put the identification of that subflow in
so
the
you
packet.
have the flow specification as a piece of metadata.
Yes, sir.
Got it. Thank you.
The use would. The covenant draft, the convent draft doesn't.
Because we're on that bullet, do you actually mean per SFC or do you mean per SFP?
P.
Well, it's certainly, I think the answer is yes.
Okay.
I certainly mean one or the other.
Okay.
Yeah.
Hey, David Olson, Sandvine. You mentioned that it's not well defined how the SF proxies and I guess SFs forward unknown. Do you think we should define how they should forward the none so that they, for example, an SF proxy will forward the packet instead of drop it?
Yeah, so when I first wrote this document, there was a hope that the NSH draft would pop out soon, and I believe there's still a hope that the NSH draft will pop out soon, and I don't want that discussion to slow down the NSH, but it needs to be documented. So I don't mind where it's documented, but yes, it should be documented.
Yeah, as what? I'm suggesting that the drop is wrong, perhaps, for some of the use cases.
Then that is a good discussion to have. And my view is that drop is right, so beer and fight in that order.
Greg Mirsky, ZTE. Okay, so when you're gonna open the floodgates and let the hell break loose?
Give us another 2 minutes so we can finish this presentation and then we move on.
Kent Leung. I know my name's hard to spell. It's like Leung. Spell that out. So my question here, especially on the flow metadata, is that how would the SFF, today you have multiple instances at a hop possibly, right? So we can load balance it, right, based on the flow information, right, which is the user data. In this case, there's no user data. There's only metadata, NSH metadata, which is bypassed by your SFF, right, basically. So I don't quite understand the details of how you support per flow metadata in this case.
So in the load balancing case specifically, so the load balancing case, an SFF, when it sees a packet, a normal user data packet, is picking between a number of SFIs to load balance.
That's right.
If there is state that needs to be installed, then that state needs to go everywhere, or the load balancing has to be aware that,
So I'll mention two things, right?
Let me put it differently.
Okay.
The way the use cases will use the next protocol none will have to be documented in individual drafts. It isn't, this document isn't going to tell you how to send metadata to everybody that will automatically be understood, because until you're describing the use of it and what you're going to ship, there's no point. So the use cases are illustrative. They're not fully specified, and let's not get hung up on trying to elaborate on all of the things. For example, I don't think we're going to require that SFFs be prepared to look for a flow TLV if next protocol is none, because SFFs generally ignore next protocol.
But I think you're making absolutely good point. Okay, that if you have load balancing among SFIs that are in some way stateful, you have a choice. You either install the state everywhere or you put that state on every packet.
So I mean, I don't think so. I think there's stateless and stateful, both cases happening, right? I think right now the key problem is actually in the user, regardless stateful or stateless, right? You're looking at the user data to do the load balancing. You're hashing or you're maintaining states, right? This requires looking into the metadata as a SFF function. So I just want to make sure that that's brought up, and we can talk more in details. But I think it will break, so-called, your existing SFF today, which is supporting multiple instances at a service hop. That's just a comment.
Yeah, okay.
Okay, we now move to the next phase of, no, we have one more presentation. I'm very sorry. We are a little bit behind schedule, but we have one more presentation. I believe Debashish is presenting. There you are.
Hello, everybody. I'm Debashish Prakasta, and I will go through this use case. So before starting the motivation, so as we see today, like a lot of this 5G applications, and with them comes the low latency requirements, are forcing a lot of these service providers to push functions as well as network functions towards the edge of the network, for example, mobile edge computing. So with this handling of user mobility and also the non-deterministic availability of compute and storage resources is extremely challenging at the edge of the network as well as within the network. So what it requires is a very dynamic and fast switching of service path between service functions, which is also known as this service indirection. If we move on to the next slide, please. So in SFC, the way service indirection is handled is using this NSH control plane protocol, where we have the service path identifier and the service index. So basically, by changing the service path identifier and the service index, a service indirection or service like the path is changed. And typically at a particular node, as a packet arrives, the policy manager is contacted, the current classification is validated, and if it is not valid, it is called, the process is called reclassification, which goes ahead and changes the SPI, and then it is forwarded back to the forwarder SFF. If we go to the next slide, please. Now, in order to improve this indirection function, like we agree that this indirection mechanism in SFC through this classification definitely can handle, but it may not be suitable for this dynamic indirection. So in this use case, the proposed SRR service function, it kind of provides an additional method to handle dynamic indirection of service request without completely relying on the reclassification mechanism. So we see it like initially those two techniques can be combined, but as well as this whole SRR function can also act independently to provide dynamic service indirection. So this proposed SRR function, what it does is typically decouples the service consumer and the service endpoint, and some of the desired features in terms of like very fast switching from the consumer to the service endpoint. And it not only relies on layer 3 protocols or layer 3 approaches like DNS, It also can use direct path mobility, avoiding the use of anchor points as we see today, and also indirect service request directly at the network level, and new methods for forwarding such as path-based forwarding and direct path routing. So this is the proposed SRR function, which is inserted between the consumer and the service provider, which tries to decouple the service forwarding, and which basically provides a complete flexibility. And it also shows the case where SRR is acting independently between the consumer and the service provider. If we go to the next slide, please. So just to get into a little bit details about this kind of deployment where the SRR is acting individually. So we have a scenario where a service consumer is and a service provider, SC and SP, and we have a single SC being serviced by, for example, multiple or more than one service providers, or say n virtual instances. So we are assuming that a service consumer or SC is changed to a service provider 1 first, and then we need to explicitly reclassify towards SPN with some out-of-band decision about which N to pick. Now, with the introduction of SRR, as we decouples the consumer and the provider, now single SC can be connected to multiple service provider. And what we see that with this kind of the requirements, we assume that it may not require reclassification. And based on instantaneous decision, it can switch the traffic flow to any of the SPs. Next slide, please. So, so that's the kind of the use case but we proposed here. So the idea is to collect feedback from the group, and we also continue extending the use case with more details and requirements. And we also plan to work on this use case and the solution in our H2020 Flame project with experiments planned for early 2018 and beyond.
Thank you. Any questions?
Questions on this presentation?
No? Okay, thanks.
Thank you.
Before we move on, can whoever has the blue sheets stick their hand up? And if anybody hasn't signed them, can they stick their hand up? And could you pass them on?
Okay, so now it's discussion. Sorry. Now it's working group members bringing up items that they would like to see the working group discuss. And yes, Greg, you can bring up whatever OAM issues you want, but you're not the only one. What I'd like to do is each topic gets brought up and then there's discussion of the topic. So Carlos, you don't bring up a topic over there because otherwise we'll get really confused. I don't want people shuffling a line. So go ahead, Tal. You can go to that one.
You got to go.
Tal Mizrahi, Marvell. So I want to bring up the issue of MD type 1. Originally, the way NSH was defined was with MD type 1 as kind of an opaque metadata that can be used for anything. And then a few drafts came up that define different formats for MD type 1. Some of them have expired, and actually I don't know what's going on with those. Some of them are still there on the documents page of SFC. So one way to go would be to not to adopt any of these documents, just to leave MD type 1 up to the operator or up to the vendor or whatever. Another way would be to choose a subset of these MD type 1 formats and to say, okay, we're going to adopt these. Other solutions, maybe up to the operator or up to the vendors or whatever. And another way would be to say, okay, we're going to have a single document that is going to define all the MD type 1 formats that we're going to support, and other MD type 1 formats are currently not supported. So I don't know, I think these are all the possible options. Maybe there are intermediate options. But I think it's important to decide where we're going, because right now it's not very clear what is going on with these different proposals, whether they will ever be adopted or whatever.
And you're specifically concerned on MD type 1, just to clarify.
Right, yes, okay. Because I think in MD type 2, there is at least one document that was adopted, and yep. we know what's going on with that.
Yep, okay. Do we have any responses to that?
On MD1.
Mohamed Boukader, yeah, I think that we have discussed this point during the last interim meeting, and at least the consensus we reached among the participants of the interim meeting is that it is valuable to document the MD Type 1 as informational RFCs, and the authors of the document are invited to come to the working group and proceed easily with the adoption so that we can facilitate that implementers are aware of the specifications. So I think it's just straightforward to remind the authors of this document to come here and to post the document. And I don't think as a working group we need to put the barrier high for the adoption of this kind of document and to proceed with them.
Because they're information.
Yeah, exactly. Not only for that, but also because, yeah, it helps for implementers. If you want interoperability and if we don't reveal the exact specifications, I think there is some problems that will be out there. So I think it's harmless to leave it as it is today, but I think we have a value to document it. This is for MD Type 1. For MD Type 2, it's another story. I think we have this single document which only specified a subset of the objects, but there are also other documents who are specifying other TLVs. And I think that it's also a good idea that we open the adoption for this TLVs so that we enrich the registry and people may start to play with the injection of the metadata for MD Type 2.
Yeah. On the MD Type 1, I mean, we had the chairs have a action to do a working group adoption for 2 of those documents. But I think it's fair to say that neither one of them have been updated substantially recently. So I think we'll take the action to talk to the editors of those 2 documents, get those updated, and then we'll do the call for adoption and let the working group decide whether to move forward with those. And then that's the data center allocation and the broadband.
Yeah.
And then I think I know there's one other document, there may be 2, that I think that we probably need to have discussion on the working group list as to whether we want to push for adoption of those 2, 1 or 2. I forget how many. I know there's a security one and there was another one, I think. So we'll take that action on the MD Type 1. Adrian?
This would be a new topic.
Oh,
Yes.
okay. So is there any more questions on the MD Type 1?
No, there's nobody there. Next.
No? Okay, next topic.
So my topic is to subvert the working group chair's microphone control and ask the question, does Carlos think the current NSH document is ready?
And you can go to this mic, Carlos, to respond.
Thank you for the question, Adrian. Carlos Pignataro, Cisco. We spent significant amount of time revamping the document to get it to revision 14. There's been many comments on the list on the 13, and in particular, many thanks to you, Matt, for the very comprehensive review. That helped the document a lot. From where I saw things as of this morning, the document was ready. Joel reminded me that there's one additional question for the working group in regards to allowing explicitly, disallowing, permitting, etc. Hybrid MD types within an SFP, meaning an SF receiving MD type 1 and sending MD type 2.
Yeah, Med had called our attention to it. We missed it. Sorry, Med. Carlos will send a note to the list and we'll get that dealt with.
So we want to hear, if there's any particular points of view on that one. Otherwise, we really think the document is ready.
Yeah, there was a lot, Adrian, there was a lot of email gone backwards and forwards, both with revision 13 and 14. So hopefully we're at a stage where we're ready.
Yeah.
Apart from that one last point.
Yeah, I do think that the document is currently stable compared to previous versions. I think there's a good work that has been done on this on the specifications. But back to the Adrian question, if there are some void aspects that are still in the specification. So I would just give an example. If the presentation from Adrian about the specification of the null value, for instance, for me, if you are in a normal world, I would
take the text from the Adrian draft and put it in the NSH document. This is the normal I would proceed, but it's up to us as a working group to decide whether this will delay the NSH specification or not. I don't get that we are in. I don't think if we delay the sending the document to ELIA by 2 or 3 weeks in order to handle, for instance, the integration of the null value in the NSH document, I would prefer that path. There is another item which is not current. For instance, if you go to the document, you will say that the values 0 are reserved, but there is no justification why these values, for instance, are reserved there, and what will be the behavior of the implementation if this kind of value shows up. This kind of stuff, I think they're only minors, Carlos, but I think that it's really worth to go through the document and to say, if there are a value which is not specified on the document, what will be the behavior of the implementation? I already sent a pointer in the mailing list to remind that this is an open issue that we have since the interim meeting. It's up to us to decide whether we ignore it or not, but I didn't heard an answer from your side. So it's just fine by me if you want to proceed and to progress the document, but I think it's just pity to not wait for 1 or 2 weeks to fix, for instance, the integration of the Adrian text into the NSH and this kind of final check. But it's up to us.
In regards to the reserve values, I'm pretty sure we actually fixed that. If there's one that I missed, and again, send me a pointer to the one that I missed. That's an easy fix. I want to make sure that the working group doesn't miss the big picture and goes to perfection when things are better than good enough right now. That's at the end of the day my opinion.
We don't want to go round and round in circles any longer. It's been long enough. But I do think, and I know Joel agrees with me, if you can provide specific text for Adrian's points that he made in his presentation, I would agree that makes sense to add that to the document and with the editor. But we want to see specific text and we want to see it like soon because this document has been going for way too long.
Yes, and I would like the document to progress. So I take the action points to propose some text and I work it with Adrian and send if Adrian agrees.
If Adrian agrees, of course.
Yeah, and we will share that with you. Yeah.
But it makes sense to add that, I think, Adrian, if you're in agreement. But we want to get that text and we want to get it done soon. Okay.
We've had a bit of, oh, I just thought of another issue. Oh, I just thought of another issue. Well, I know from lots and lots of documents, you can always think of another issue in almost every document I've turned out. So, but if we can get it quickly, we'll put it in. Kent, next topic.
Yeah, new topics. I'll bring up because there's been a lot of email discussions on Ronaldo's, reverse packet generation draft. So, I've been trying to collect, basically, and get some rough consensus because I think we should revise that, with a kind of standards approach that everybody can start implementing, and interoperable. So I think probably most people have seen some of the emails, but I think we're down to at least 2 options out of the initial 4 that was in the draft. And I don't want to rehash all the discussions here, obviously. So I think people understand the trade-offs. Basically, one option is using, I'll summarize it for people here, right? Let's call it one option is using SPI and SI, basically, as a way of showing both directions of the flows, or 2 flows for a connection, for example. And the second option is basically SPI indicates basically the flow, right, which is the direction, one for each direction of the connection, right? So we're basically down to those 2. And based on the email discussion, it seems like I see more leaning toward the second option, basically right now. I don't know how should we get some kind of progress, right? So.
Let's continue that conversation on the mailing list. And if people aren't familiar with the email thread, then go take a look at that. And obviously, Ken's looking for those comments. And I think it is an area we need to progress.
Okay, Greg Mirsky, ZT. Okay, what the heck? Let's do it. Definition of OEM. We had a discussion on what is interpretation of O bit or OEM bit. And I think that Adrian draft highlights this issue that we have at hand, because I'll use terminology from RFC 7799. We are discussing, we are proposing, and we've done it today, two mechanisms, OEM mechanism, active OEM and hybrid OEM. So the active OEM is then when we generate a content, a packet, message, and we send it down to SFC, and this packet is generated in the domain and terminated in the domain. In the hybrid OEM, we add on or insert some information into NSH or into the packet that has OEM use. That will be a hybrid OEM. So the question from my side to me is that what O bit signifies when the O bit is set. Does it signify active OEM? Does it signify any OEM? And how I can differentiate between the two?
Okay. What we've written in the document and what the working group worked over very extensively and reached agreement on is that the O bit being set means there is OEM significance here. That is in the OS relative to NSH. It doesn't tell you where to find it. It doesn't tell you what the processing is. It tells you this is going to need special processing. If you're not prepared to do some special processing, then you probably better drop this on the floor because you're not going to do the right thing. If you are prepared to do the special processing, then you know where to look for your special processing. That there is a separate question, which you've raised with me directly, but which is really for the working group. Do we want to have two mechanisms or one mechanism for how we represent some of this stuff, or three mechanisms or seven? I mean, we can make up lots. We're good at that. Or should we say there's only one? And that is a topic for the OEM framework document that is being worked on, not to mandate the mechanism, but to talk about, do we need there to be a single one or do we need multiple? That's something that the framework document can very well address. But all that the NSH document is telling you is, this OBIT says this packet needs OEM processing. This NSH packet, this thing you are getting, after that, you need to know something else to know how to do it. It doesn't tell you how, because we're not going to mandate in NSH a debate that is clearly going to take many months before it converges. Well, it is our job as chairs to drive it to convergence, but it's not going to happen quickly.
Right. Okay. Joe, thank you for helping me to state the question more clearly. So again, from point of active OEM, there are two options. One option is to include it in a payload. Another option is to use protocol none, next protocol none, and then include metadata. The hybrid OEM is clearly goes in the metadata. So if both cases, if all three cases are signified by a single OEM bit, I have really hard time envisioning their hardware support being efficient for the OEM.
Look, if we agree on the mechanisms, if we agree there's one or we agree there's three, it doesn't matter. If we agree on the mechanisms, then hardware which supports the mechanisms will be able to be triggered by the presence of the O-bit. Even if there's multiple mechanisms, if we agree on there being only one, then the hardware triggers only one from the O-bit. The O-bit is not the full solution. We understand that. It is not the full answer. You cannot build hardware which will do OEM from just the O-bit because you have no idea what to do. All you can do is put a hook in your hardware that says, I better design in something to do it. I can't get around that because we haven't got agreement. I can't just magically declare, here's what you put in the hardware. Neither can you.
Again, I agree. That's effectively what the problem I see. And I would like that framework to be a place where we come to the solution.
Yes, the framework document is a good place to discuss it.
OEM framework it is.
Yeah.
And we are out of time.
We are out of time. So Okay, thank you. Where's the blue sheet, please?
Can you unplug me, please? Since I know who the chairs of the next session are, and I don't want them running me over. And they will. Hello, Tal, thank you. Well, find the blue sheets, because we need them. Thank you. Oh, well, I'm a human clicker, it works. I've been a human clicker more than once.